Hello there, and welcome to The Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into one of the smallest frontiers imaginable, a place so tiny that even the idea of place begins to blur. But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe, only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a quiet joy to see all the different corners of the earth where these thoughts drift through. Now, you might want to dim the lights, maybe let a soft hum fill the room and allow your mind to slow just a little as we begin. There is something deeply human about wanting to look closer. From the very beginning, long before science had a name, there was curiosity, a quiet wondering about what things are made of, a question that never quite leaves us, even as we grow older. What lies beneath what we can see? At first, our eyes were enough. We could observe the world around us, trees, rivers, the movement of clouds. But soon, that wasn't enough. We wanted to see the smaller details hidden just beyond our natural vision. So we built tools, simple lenses at first, bending light just enough to reveal something new. Tiny worlds began to emerge, cells, small organisms drifting in water, textures on leaves that had always been there, waiting quietly to be noticed. And then, as time passed, we built better tools, microscopes that could peer deeper, revealing structures so small that they felt almost unreal. Eventually we saw atoms, the building blocks of matter itself, tiny, delicate arrangements, like miniature solar systems, though not quite as solid as they first appeared. But even that was not the end, because once we reached the atom, we asked the same question again. What lies beneath that? And so, we built something far more powerful than any microscope. Machines that didn't rely on light alone, but on energy itself. These machines, vast, complex and quietly humming beneath the surface of the Earth, allowed us to explore regions of reality far smaller than anything visible. In places like the Large Hadron Collider, particles are accelerated to incredible speeds, and then gently, or sometimes not so gently, brought into contact. From these interactions, we learn what cannot be seen directly. It's a bit like trying to understand the shape of something hidden in the dark by listening to the sound it makes when touched. And what we discovered was surprising. The deeper we looked, the less solid things became. Atoms were not indivisible. They contained smaller components, protons, neutrons, electrons. And those too were not final. Inside protons and neutrons we found even smaller entities, quarks, bound together in ways that are difficult to picture. Reality, it seemed, was not a simple stack of solid layers, but something far more fluid, more subtle. And yet, even this was not the most surprising part, because as we continue to look deeper, something strange began to happen. You might imagine that observing something is a passive act, that we simply look and the universe reveals itself like a book waiting to be read. But that isn't quite true. To see something, we must interact with it. Even something as simple as looking involves light. Tiny packets of energy travelling from a source, bouncing off an object and entering your eyes. Without that interaction, there is no image, no perception, no knowledge. And at everyday scales, this interaction feels gentle, harmless, almost invisible. But as we begin to explore smaller and smaller structures, that interaction becomes more significant. To see something very small, we need a very precise touch. And that precision requires something stronger, more focused, more energetic. It's a little like trying to feel the shape of something delicate while wearing thick gloves. If your touch is too broad, too soft, you miss the details. So you press a little harder, a little more carefully, until you can sense the finer features. But press too hard, and you risk changing the very thing you're trying to feel. At the smallest scales, this becomes unavoidable. Every attempt to observe begins to disturb. The act of looking is no longer separate from the thing being observed. It becomes part of the process itself. And so, as we continue this quiet descent into smaller and smaller realms, a subtle tension begins to form. On one hand, our desire to understand drives us forward, to look deeper, to uncover what lies beneath. But on the other hand, the deeper we go, the more fragile the act of observation becomes. Reality does not simply reveal itself. It responds. It shifts, gently at first, and then more dramatically. And somewhere, far beyond the scale of atoms and quarks, beyond anything we have ever directly experienced, there is a boundary, a place where the rules we know begin to soften, blur, and perhaps even dissolve. But we're not there yet. For now, we're still on the journey inward, still learning how to see. And as we move forward, we'll begin to understand something quite surprising, something that quietly reshapes the way we think about knowledge itself. Because to see smaller is not just to look closer, it is to enter into a conversation with reality, one where every question we ask leaves a trace behind. And so, as this gentle exploration continues, we begin to follow that idea just a little further into the nature of light itself and the quiet limits hidden within the way we see. As the thought settles that seeing is not simply observing but interacting, we can begin to follow that idea a little further into something that feels familiar yet quietly mysterious: light. It is everywhere around you, even now, perhaps softly filling the room or faintly glowing from a distant source. It allows you to see, to recognize shapes, to move through the world with ease. And yet light is not just illumination, it is a messenger. Every time you see something, light has travelled from a source to an object and then gently into your eyes. It carries with it a subtle imprint of the world, a kind of quiet whisper about shape, texture and distance. But there is something else hidden in this process, something that determines not just whether you can see, but how clearly. If you imagine light not as a beam, but as a wave, like the slow rise and fall of water in the ocean, it becomes easier to understand. Some waves are long and gentle, stretching far across the surface. Others are short and tightly packed, rising and falling quickly, and just like waves. In the ocean, light has a kind of length to it, not something you can see directly, but something that shapes how it behaves. Now, imagine a small object floating on water. If the waves are very large, long and smooth, the object simply rises and falls with them. The wave barely notices it. There is little disturbance, little detail. But if the waves are small, tightly spaced and energetic, they begin to interact more strongly with the object. They scatter, reflect, and reveal its shape more clearly. In a quiet way, this is how seeing works. To notice small details, the waves of light must be small enough to interact with those details. If the waves are too large, they simply pass over, smoothing everything out. So if you want to see something very small, you need light with very small waves. And here is where something subtle begins to emerge. Because smaller waves are not just smaller, they're also more energetic. You might imagine it like tapping on a surface. A gentle, slow tap carries little energy, but a rapid, sharp tap carries much more. The tighter the motion, the more energy it holds. Light behaves in a similar way. When its waves are shorter, more compressed, it carries more energy. So to see smaller things, we need light that is more energetic. At first, this is not a problem. Visible light, the kind your eyes detect, is perfectly suited for everyday life. It allows you to see objects around you, down to the scale of tiny details like the strands of hair or the texture of fabric. But if you try to use this same light to see something much smaller, like the structure of an atom, it simply isn't enough. The waves are too large. They glide over the object without revealing its finer features, just like long ocean waves passing over a small boat. So, scientists turn to other forms of light, ones with shorter waves and higher energy. X-rays, for example, have much shorter waves than visible light, and with them, we can begin to see structures far smaller, arrangements of atoms within crystals, patterns hidden deep inside matter, and if we go even further, using even higher energy, we can probe deeper still. But here, something begins to shift, because increasing the energy of light is not just a matter of seeing better, it changes the nature of the interaction itself. At low energies, light feels gentle, it illuminates without disturbing, but as the energy increases, the interaction becomes more forceful, more intrusive. It's a bit like shining a soft flashlight versus a powerful beam that begins to heat what it touches. And as we continue this journey inward, trying to see smaller and smaller details, we find ourselves needing light that is not just precise, but intense. And at this point, another idea quietly enters the picture. Light is not just a wave. It can also behave like a stream of tiny particles, each carrying a small packet of energy. You might picture them as individual messengers, each one delivering a tiny nudge to whatever it encounters. And when these messengers carry more energy, their touch becomes stronger. So now, the act of seeing begins to change. It is no longer just about observing. It becomes an interaction with consequences. To see something extremely small, we must use these high-energy messengers. But when they arrive, they do not simply bounce off gently. They push, they disturb, they alter. And so, a quiet trade-off begins to emerge. To gain more detail, we must accept more disturbance. To see more clearly, we must interact more strongly. And this is not a limitation of our tools. It is woven into the very nature of light itself. As this idea settles in, it brings with it a subtle shift in perspective. We often imagine that if we just had better technology, sharper instruments, more powerful tools, we could see anything, no matter how small. But reality is not simply waiting to be revealed. It has its own conditions, its own quiet boundaries. And as we continue to follow this path into smaller and smaller scales, we begin to encounter those boundaries more directly. Because there comes a point where increasing energy does not just improve our view, it begins to interfere with it. And eventually, as we will gently discover, it may even prevent us from seeing further at all. But for now, we are still at the threshold of that realization, still learning how light behaves, how waves reveal detail, and how the simple act of looking carries with it more depth than it first appears. And as this understanding deepens, we begin to see that light is not just a tool for observation. It is a bridge between what we wish to know and how the universe allows itself to be known. As the image of waves settles gently in your mind, rising and falling, revealing and concealing, we can begin to notice something a little more unusual, because light, as it turns out, does not always behave like a smooth, continuous wave. Sometimes, it arrives in tiny, discrete moments, almost like individual taps. Imagine standing in a quiet room, listening carefully. Instead of a steady hum, you begin to hear faint, separate clicks, each one subtle but distinct. Not a continuous flow, but a series of gentle arrivals. In a similar way, light can be thought of not just as a wave, but as a stream of tiny packets, each one carrying a small amount of energy, arriving one after another. These packets are often described as particles, but not in the solid, familiar sense. They are more like little bundles of energy, each one shaped by the wave it came from. You might picture them as ripples that have gathered themselves into individual droplets, still connected to the idea of a wave, but now arriving one by one. And this changes something important, because if light comes in these tiny packets, then the energy it carries is not spread out smoothly. It is delivered in small, concentrated amounts. Each packet brings its own little push. At everyday scales, this makes very little difference. The packets are so small, so gentle, that their individual impacts blur together. Light feels continuous, soft, almost weightless. But as we begin to explore smaller and smaller details, those individual pushes start to matter. To see something extremely small, we need light with very tightly packed waves. And as we quietly discovered before, that also means each packet of light carries more energy. So now, instead of a soft stream, we're working with something sharper, more focused. Each tiny packet arrives with a little more force, and here, the act of observation becomes even more delicate. Imagine trying to examine a fragile object, something so light that even a gentle touch might move it. If you tap it too softly, you learn nothing. But if you tap it too strongly, you risk changing it entirely. At very small scales, this becomes unavoidable. To see clearly, we must use these energetic packets of light. But when they arrive, they do not simply bounce away. They interact, they transfer energy, they leave a trace. And so, the boundary between seeing and affecting begins to fade. This idea was one of the quiet revolutions in physics. For a long time, it was assumed that we could observe the world without disturbing it, that with the right tools we could uncover reality as it truly is, untouched by our presence. But light, in its particle-like form, tells a different story. Every act of observation carries a cost, not in effort, but in influence. To see something smaller, we must send in these high-energy messengers, and each one, in its own small way, nudges the system we're trying to understand. At larger scales, these nudges are insignificant. But the scale of atoms and beyond, they begin to shape the outcome. And there's another subtle detail hidden within this relationship. The energy of each packet of light is connected to how tightly its wave is packed. The shorter the wave, the more energetic the packet. So as we reach for smaller and smaller details, we are not just refining our vision, we're increasing the intensity of our interaction with reality. It is a quiet escalation. At first, it feels like progress. We see more, understand more, uncover deeper layers. But beneath that progress, something else is building. Attention. Because the very tools that allow us to see more clearly also begin to interfere more strongly. And eventually this tension becomes impossible to ignore. But before we reach that point, there is another step in this journey. One that makes the picture even more intriguing. Because it is not just light that behaves this way. Matter itself, things we usually think of as solid, stable, and well-defined, can also exhibit this strange dual nature. They too can behave like waves, and when we begin to use matter itself as a tool for observation, something remarkable happens. The distinction between what we use to observe and what we are observing begins to blur. Imagine trying to examine a pattern in water, using more water. The tool and the subject become intertwined. And as we continue this quiet descent into smaller scales, this blending becomes more and more pronounced. Particles are no longer just objects. They're also waves. Interactions are no longer just collisions. They are exchanges of energy, of motion, of uncertainty, and through it all one idea continues to deepen. To see is to interact, to understand is to participate. Reality is not simply laid out before us, waiting to be discovered like a hidden map. It responds subtly but persistently to the ways in which we try to uncover it. And so, as we move forward, we begin to ask a new kind of question. If light behaves like both a wave and a stream of particles, could the same be true for everything else? Could matter itself, the very substance of the world, carry within it this same quiet duality? As that thought drifts gently into place, we follow it onward, into a deeper realization that the boundary between waves and particles, between observer and observed, may not be as clear as it once seemed. Let that idea rest quietly for a moment. That light can move like a wave and also arrive in tiny separate touches, and something even more unusual begins to form. Because it is not only light that behaves this way, matter itself, the things we usually imagine as solid, stable, and clearly defined, can also take on this quiet, wave-like nature. At first, this might feel a little difficult to picture. After all, when you hold an object in your hand, it does not feel like a wave. It feels firm, certain, present in a very definite way. But as we begin to look closer, much closer, that certainty begins to soften. In the early 20th century, scientists began to notice something subtle. When very small particles, like electrons, were sent through carefully designed experiments, they did not behave like tiny solid spheres. Instead, they behaved more like waves. They spread out. They interfered with themselves. They created patterns that resembled ripples overlapping on the surface of water. It was as if each particle was not confined to a single point, but existed as a kind of gentle blur, a possibility spread across space. You might imagine dropping a pebble into still water. The ripples expand outward, overlapping and interacting in delicate ways. Now imagine that instead of one ripple, there is something that behaves like many possibilities at once, quietly exploring different paths. And only when it is observed does it seem to settle. This idea, often called wave-like behavior, is not just a mathematical trick or a convenient description. It has been observed again and again in experiments so carefully performed that there is little room for doubt. Electrons, tiny components of atoms, can act like waves, and more surprisingly, so can other particles. Even entire atoms, under the right conditions, can display this soft spreading behavior, and this leads to a quiet realization. The deeper we look, the less the world resembles a collection of solid objects, and the more it begins to feel like a pattern of motion, of possibilities, gently unfolding. But this wave-like nature is not just something curious or abstract. It has a very practical consequence, because just like light waves, these matter waves also have a kind of size to them, a wavelength that determines how finely they can explore the world. If the wave is broad and spread out, it cannot resolve small details, but if it is tightly compressed, it can reveal finer structures. And just like before, achieving smaller wavelengths requires more energy. So now we find ourselves in an interesting position. We are no longer limited to using light to see small things. We can also use particles, like electrons, as tools for observation. In fact, in some cases, electrons can be even more effective than light. Their wave-like nature allows them to probe extremely small distances, revealing details that would otherwise remain hidden. This is how some of the most delicate structures in nature have been uncovered. By sending streams of electrons toward a target and observing how they scatter, we can build a picture of what lies beneath the surface. It is a bit like sending gentle ripples across a hidden landscape and listening carefully to how they return. From those returning patterns, we begin to reconstruct the shape of what we cannot directly see. And through these methods, scientists were able to discover something remarkable. Inside the proton, once thought to be a simple, indivisible particle, they found smaller components, tiny entities known as quarks, bound together in intricate ways. Each time we looked deeper, reality revealed another layer, another level of structure, another quiet complexity. And yet, something else was also becoming clear. As we pushed to smaller and smaller scales, the energy required to probe those scales continued to rise. To explore the structure of atoms, modest energies were enough. To peer inside the nucleus, much higher energies were needed. And to uncover the quarks within protons, even greater energies were required. It was a steady progression, a kind of ladder where each step downward into smaller scales required a stronger push, a more energetic probe. And for a time, it seemed as though this process could continue indefinitely, that no matter how deep we went, we could always go further, simply by increasing the energy of our tools. But beneath this steady progress, a quiet question was forming. Is there a limit? Is there a point where increasing energy no longer helps us see more clearly, but instead begins to change the rules entirely? Because as we continue this descent, using more energetic particles, focusing them into smaller and smaller regions, we are not just observing reality, we are concentrating energy into tiny spaces, and energy, as we will soon begin to see, is not something passive. It has weight, it has influence, it can shape the very fabric of the space around it. So while it may seem that we are simply refining our vision, something deeper is happening. We are pressing into reality with increasing intensity, and at some point, reality begins to respond, not gently as it did before, but in a way that alters the very stage on which everything takes place. The smooth, stable backdrop we call space begins to bend, and when that happens, the journey inward takes on an entirely new character. But for now, we are still just at the edge of that transformation, still learning that matter is not as solid as it seems, that particles can behave like waves, and that the tools we use to observe the universe are more deeply connected to it than we might have imagined. And as this understanding settles softly into place, we can begin to follow it just a little further, into the quiet realization that seeing is not only about resolution, but about interaction, and that every step deeper carries with it a greater consequence. As the image of waves continues to ripple outward, and the idea settles that even matter itself can behave like something soft and spread out, we arrive at a realization that is both simple and quietly profound. To see is to touch. It may not feel that way in everyday life. When you look at an object across the room, it seems as though nothing passes between you and it. No contact, no disturbance, just a clear and effortless perception. But beneath that calm surface, something is always happening. Light is travelling. Tiny packets of energy are leaving a source, moving through space, gently meeting the surface of an object and then continuing onward until they reach your eyes. Each one carries information, each one makes contact, and it is through this contact that the image forms. So even in the simplest act of seeing, there is interaction. At larger scales, this interaction is so subtle that it feels invisible. The object remains unchanged, or at least any change is too small to notice. But as we continue to move into smaller and smaller realms, this gentle interaction begins to matter more. Imagine trying to examine a tiny speck of dust floating in the air. If you shine a soft light on it, you might catch a glimpse of its outline, but if you want to see it clearly, to understand its structure, you might need a brighter light, a more focused beam, and that beam carries energy. When it strikes the dust, it does not simply reveal it. It nudges it. It shifts it, ever so slightly. Now imagine something far smaller than dust. Something so delicate that even the smallest nudge becomes significant. At that scale, the act of seeing begins to influence what is seen. This is not a flaw in our instruments. It is not a limitation of technology. It is a feature of reality itself. Every attempt to observe involves an exchange, energy moving from one place to another, altering the system in subtle ways. And as we have seen, to explore smaller details, we must use higher energy, stronger interactions, more concentrated touches. So the deeper we look, the more we disturb. It is a quiet trade-off. You gain clarity, but you lose stillness. You uncover detail, but you introduce motion. And eventually, this trade-off becomes impossible to ignore. There is a well-known idea in physics that captures this balance, a kind of gentle rule that governs how precisely we can know certain aspects of a system. It tells us that there are limits, not because of our tools, but because of the nature of reality itself. If you try to pinpoint exactly where something is, you lose the ability to know exactly how it is moving. And if you try to measure its motion with great precision, its position becomes less certain. It is as if reality resists being pinned down in both ways at once. You might imagine trying to photograph a small, fast-moving object in a dim room. If you use a very short flash of light, you can capture its position sharply, but the flash itself may disturb its motion. If you use a longer exposure, you might see its path more clearly, but its exact position becomes blurred. There is no perfect balance, only a quiet compromise. At the smallest scales, this is not just a practical limitation, it is fundamental. Particles do not simply have fixed positions and motions waiting to be measured. Their properties are intertwined in a way that prevents complete certainty. And this brings us back to the idea of interaction. To measure position, we must touch the particle with something, often a photon, a tiny packet of light. But that touch transfers energy. It changes the motion. And so, the more precisely we try to locate the particle, the more we disturb its movement. It is not that we are clumsy observers, it is that observation itself carries influence, and this influence cannot be removed, even in principle. This realization marks a quiet turning point in our journey. Up until now, we might have imagined that with enough care, enough precision, enough refinement, we could observe reality exactly as it is. But here, that idea begins to soften. Not everything can be known with complete clarity, not because it is hidden, but because the act of knowing changes the thing we seek to know. And yet, this is not something to be frustrated by. It is not a barrier, but a glimpse into the deeper structure of reality. A structure where certainty gives way to possibility, where precision is balanced by influence, and where the observer is never entirely separate from the observed. As we continue this gentle descent, this balance becomes more pronounced, because the tools we use, the light, the particles, the energy we concentrate, grow stronger, and with that strength comes greater disturbance. So the question quietly evolves, not just how small we can see, but how much we can see without changing what is there. And as we follow that question just a little further, we begin to encounter a limit that is not just subtle, but absolute. A boundary where increasing energy no longer brings clarity, but instead begins to reshape the very fabric of space itself. If we stay with that thought for a moment, that seeing is never entirely gentle, that every observation carries a quiet touch, we begin to notice a deeper pattern forming beneath it all, a pattern that is not loud or dramatic, but steady, quietly unavoidable. There is a balance at the heart of things, a kind of trade-off that cannot be escaped. No matter how careful we are, no matter how refined our tools become, you might begin to feel it already. The more precisely we try to know where something is, the less certain we become about how it is moving, and the more clearly we understand its motion, the less sharply we can define its position. It is not a flaw. It is not a limitation of skill. It is simply how reality behaves. You can imagine it like trying to hold a small, restless object in your hand. If you grip it tightly to fix its position, it resists, shifting its motion. But if you allow it to move freely, you lose track of exactly where it is. There is always a balance. At everyday scales, this balance is so subtle that we rarely notice it. Objects appear still. Their motion and position seem well defined. The world feels stable. But as we move into smaller and smaller scales, that stability begins to soften. Particles do not sit quietly in place. They move. They shift. They exist in a kind of gentle uncertainty, and the more closely we try to observe them, the more that uncertainty reveals itself. It is as if reality prefers not to be pinned down too precisely. And perhaps the most surprising part is this. Even if we imagined a perfect instrument, one without flaws, without noise, without any imperfections, this trade-off would still remain. Because it is not coming from the instrument, it is coming from the interaction itself. To know position, we must interact in a way that defines location. To know motion, we must interact in a way that reveals change. But these interactions are not neutral. Each one shapes the system in a different way. And so, we are left with a gentle but firm boundary, a limit not of technology, but of possibility. This idea, often introduced as a principle in physics, can feel abstract when described in formal terms. But at its heart, it is something quite simple. There is no way to fully separate the act of observing from the thing being observed, and there is no way to know everything at once. But as we sit with this idea, something else begins to emerge, because until now, the trade-off has been between different kinds of knowledge, position and motion, clarity and disturbance. But there is another dimension to this balance, one that becomes more important the deeper we go. Energy. Every interaction we use to observe carries energy. Light carries energy. Particles carry energy. Even the smallest probe must deliver some amount of influence in order to reveal what lies beneath. And as we have seen, to explore smaller scales, we need more concentrated interactions, more energy, focused into smaller regions. At first, this feels manageable. We increase the energy, and we gain more detail. It is a straightforward exchange, but slowly, almost imperceptibly, the nature of that energy begins to matter more. Because energy is not just a passive quantity. It has effects. It can move things. It can change things. And, as we will soon begin to understand more deeply, it can shape the very space in which everything exists. You might imagine pressing your finger gently into a soft surface. At first, the surface barely changes. A small indentation, nothing more. But if you press harder, the surface begins to deform. It bends, curves, responds to the pressure, and if you continue pressing, there comes a point where the structure itself begins to change in a more dramatic way. In a similar, though far more subtle sense, energy interacts with space. At low levels, the effect is negligible, invisible. But as the energy increases, especially when it is concentrated into a very small region, its influence grows. And this brings us to a quiet turning point. Until now, increasing energy has helped us see more. But what if, beyond a certain point, increasing energy begins to change the very stage on which we're observing? What if the space we are probing is not fixed and passive, but something that can respond? Something that can bend, shift, and even close in on itself? This possibility may seem distant at first, but it is not. Because the deeper we go, the more energy we must use, and the more energy we concentrate, the more we begin to approach a threshold, a point where the rules we've been following start to transform, where the act of observation is no longer just about disturbance, but about altering the structure of reality itself, and so the trade-off deepens. It is no longer just about what we can know. It becomes about what we can even access. Because if the act of trying to observe begins to reshape the space we are observing, then there may come a moment where the very thing we are trying to see becomes hidden, not by distance, but by the consequences of our own attempt. This is where the journey begins to change, where the quiet balance we have been following leads us toward a boundary, not a sharp edge, but a soft, inevitable limit. And as we continue, we will begin to see how energy, something we once used as a tool, becomes something far more powerful, something that does not just reveal reality, but participates in shaping it. As the quiet balance begins to take shape, between knowing and disturbing, between clarity and influence, another idea gently rises to the surface. If seeing requires interaction, and interaction requires energy, then knowledge itself begins to carry a kind of cost, not a cost in effort or time, but in energy. To understand something more deeply, we must engage with it more strongly. And as we've seen, when we try to explore smaller and smaller structures, that strength must increase. It is a simple pattern at first. To see something large, a gentle interaction is enough. Soft light, low energy, minimal disturbance. To see something smaller, we need something more precise, more focused, more energetic. And so, as we descend into the hidden layers of reality, the energy we use begins to rise. At first, this feels like progress. Each increase in energy reveals something new. Atoms once invisible come into view. Their internal structure begins to unfold. Then the nucleus, dense, compact, holding most of the mass. And within that nucleus, something even more subtle appears. Quarks, tiny components that make up protons and neutrons. Not objects in the usual sense, but entities bound together in ways that are difficult to picture, held by forces that do not behave like anything we experience in everyday life. And how did we discover them? Not by looking directly, but by using energy. Scientists built machines, vast and intricate, that could accelerate particles to extraordinary speeds. These particles were then directed toward targets, allowing them to interact in controlled ways. From the patterns of these interactions, from the way particles scattered, deflected, and transformed, a picture began to emerge. It was like listening to echoes in a dark cavern, and slowly reconstructing the shape of the space from the way sound returned. One of the most remarkable examples of this is the Large Hadron Collider. Hidden beneath the ground, stretching across many kilometers, it accelerates particles to speeds incredibly close to the speed of light. When these particles meet, they release energy in concentrated bursts, revealing structures that cannot be seen in any direct way. It is often described as the most powerful microscope ever built, but instead of using lenses and light, it uses motion and energy. And with it, we've been able to explore regions of reality that are unimaginably small. But as we follow this path, something subtle begins to shift. At first, increasing energy feels like a reliable strategy, a simple rule. More energy leads to deeper insight. But as we push further, the cost begins to rise more quickly. To probe smaller distances, we must concentrate energy into smaller regions, and this concentration becomes extreme. Imagine focusing all your attention on a single point. Then imagine gathering not just attention, but energy, compressing it, narrowing it, directing it into a tiny space. At first, nothing unusual happens, but as the concentration increases, the effect becomes more noticeable. Because energy does not just pass through space, it influences it. It presses into it. It has, in a quiet but profound sense, a kind of presence. And this leads us to an important realization. The deeper we try to see, the more we are not just observing reality, but pressing into it. And there is a limit to how much precious space itself can absorb without responding. You might imagine stretching a piece of fabric. At first it holds its shape, but as you pull harder, it begins to deform. The surface changes, the geometry shifts, and if you continue, there may come a point where the structure itself gives way, in a similar way as energy is concentrated into smaller and smaller regions. The fabric of space begins to respond. At everyday scales, this effect is far too small to notice, but at the scales we are now approaching, it becomes significant, and this marks a turning point in our journey. Because until now, energy has been a tool, something we use to uncover deeper layers of reality. But beyond a certain threshold, energy becomes something else. It becomes an influence that shapes the very stage on which reality unfolds. And so, the simple rule, more energy leads to better resolution, begins to soften. Because at some point, adding more energy does not just help us see, it begins to interfere, it begins to alter, and eventually, it may even prevent us from seeing further at all. But before we reach that boundary, it is worth pausing for a moment and appreciating just how far this journey has taken us. From the scale of everyday objects, to atoms, to the inner structure of protons. Each step has required a deeper interaction, a stronger engagement, a greater investment of energy. And at each step, reality has revealed something new, something unexpected, something that reshapes our understanding of what the world is made of. But now, as we stand at the edge of even smaller scales, something begins to feel different. The path forward is no longer smooth, the rules are no longer simple, and the question quietly changes. It is no longer just, how much deeper can we go? But rather, what happens when the act of going deeper begins to change the world itself? And as that question gently unfolds, we begin to move toward a realization that is both surprising and inevitable, that there may be a point where seeing more no longer means knowing more. Let that idea rest gently, that knowing comes with a cost, paid quietly in energy, and something subtle begins to shift beneath the pattern. Until now, the journey has felt almost reassuring. Each step deeper into reality followed a simple rhythm. You wanted to see something smaller, so you used more energy. You focused your tools more precisely, and the universe responded by revealing another layer. Atoms became visible, then their inner structure, then the quarks within protons. Each time the same quiet rule seemed to hold. Push harder, and reality opens. But now, something begins to shift. The pattern does not break suddenly. There is no sharp boundary, no dramatic warning. Instead, it softens, gently, almost imperceptibly. At first, increasing energy still works. You refine your measurements, you sharpen your view, the details become clearer, more precise. But the cost begins to rise more steeply. To gain just a little more clarity, you must use significantly more energy. It is like climbing a hill that slowly becomes steeper. Each step forward requires more effort than the last, and yet you continue, because the promise of deeper understanding is still there, but then something changes, not in your tools, but in the nature of what you are observing. You might imagine shining an increasingly powerful beam of light onto a delicate surface. At first, the surface reflects the light, revealing its texture. Then, as the beam grows stronger, the surface begins to warm, subtly at first. And if you continue increasing the intensity, there comes a moment where the surface no longer simply reflects. It begins to change, it deforms, perhaps it melts, or shifts, or loses the very structure you were trying to observe, and at that point, the act of seeing has crossed a threshold. You're no longer just observing, you're altering. Something similar begins to happen as we push deeper into the smallest scales of reality. The energy we use to probe becomes so concentrated, so intense, that it no longer behaves like a gentle tool. It becomes something more active, more intrusive, and this is where a quiet but profound question begins to emerge. What if there is a point where increasing energy no longer reveals smaller details, but instead begins to interfere with the very structure we are trying to examine? What if the act of looking more closely begins to obscure what we are looking for? At first, this idea might feel counterintuitive. After all, we are used to thinking that better tools always lead to better understanding, sharper lenses, clearer images, more precise measurements. But at these scales, the rules begin to change, because the stage on which everything exists, space itself, is not fixed. It is not rigid. It can respond. It can bend and stretch and shift under the influence of energy. At everyday levels, this effect is far too small to notice. But as energy becomes more concentrated, especially within extremely small regions, its influence grows, and slowly, almost quietly, the space we are probing begins to change. It is no longer a passive background. It becomes part of the interaction. Imagine standing on solid ground. At first it feels stable, unmoving. But if you were to place enough weight in a small area, the ground might begin to compress, to sink, to reshape under pressure. Now imagine that this ground is not just beneath your feet, but is the very fabric of space itself, and the weight is energy. As we focus more and more energy into smaller regions, we are, in a sense, pressing into space, and space begins to respond. At first, the response is subtle, but as the energy increases, the response becomes more pronounced, and eventually, it becomes impossible to ignore. This is the turning point, the moment where the simple relationship between energy and resolution begins to break down. Because now increasing energy does not just sharpen our view, it changes the conditions under which we are observing. It alters the geometry of the space we are probing, and this leads to a surprising consequence. Beyond a certain point, adding more energy does not help us see smaller structures. Instead, it begins to hide them. It is as if the universe gently closes a door, not out of resistance, but as a natural outcome of its own structure. The more we push, the more the system responds, and eventually, the response becomes so strong that it prevents further exploration. But we're not quite at that boundary yet. We're only beginning to sense its presence. A subtle shift in the pattern, a quiet hint that the journey inward may not be endless. And as we follow this idea just a little further, we begin to encounter something even more remarkable. Because the response of space to energy is not random. It follows its own set of rules. Rules that were first uncovered through a very different line of thinking. One that connects energy, motion, and the shape of space itself. And through those rules, we will begin to see that space is not just a backdrop for Events. It is an active participant, one that can curve and bend and under the right conditions form something truly extraordinary. A boundary from which nothing returns, a region where even light cannot escape. And as that possibility begins to take shape, we move gently toward the next stage of our journey, where energy becomes weight and space begins to curve in response. As the quiet tension lingers, the sense that pushing deeper into reality is no longer as simple as it once seemed, we begin to notice something even more subtle, something that, at first, feels almost counterintuitive. Energy has weight, not in the way a stone does, resting in your hand, not in the way an object presses down on the ground beneath it, but in a deeper, more delicate sense. Energy carries influence. It shapes the space around it. You might imagine space as something empty, a kind of silent backdrop where events unfold, where objects move, where light travels. It feels passive, neutral, untouched by what happens within it. But that picture, as it turns out, is incomplete. Space is not just a stage. It is something that can respond. This idea began to take form through the work of Albert Einstein, who saw that what we think of as gravity is not simply a force pulling things together, but a gentle bending of space itself. You might picture it like a stretched fabric. If you place something light on it, the fabric barely moves. It remains smooth, almost unchanged. But if you place something heavier, the fabric dips slightly, curving inward. And if something else moves nearby, it follows that curve, not because it is being pulled directly, but because the space it moves through has changed shape. This is the quiet idea behind gravity. Objects do not simply attract each other, they shape the space around them, and that shape guides how things move. At everyday scales, this effect is so gentle that we rarely notice it. The ground feels solid, distances feel stable, space appears unchanged. But as we begin to consider more extreme situations, something interesting happens. Because it is not only objects with mass that can influence space, energy can do it too. Anything that carries energy, light, motion, even the act of concentrating energy into a small region, contributes to this shaping. You might imagine shining a beam of light across a room. It seems weightless, effortless. But if you could somehow gather enough light into a single point, its presence would begin to matter. It would no longer feel like something passing through space. It would begin to shape it. At first, the effect is almost imperceptible, a slight curvature, a gentle distortion. But as the energy increases, especially when it is focused into smaller and smaller regions, the influence grows, and this is where our journey begins to shift. Because until now, we have been using energy as a tool, something we apply to uncover hidden details, to probe deeper into the structure of reality. But now, we begin to see that energy is not just revealing reality. It is interacting with the very fabric of space itself. You might imagine pressing your finger lightly into a soft surface. At first, there is almost no change, but if you press harder, the surface begins to bend. The shape of the surface adapts to the pressure, and if you concentrate that pressure into a smaller area, the effect becomes stronger, more focused. In a similar way, when we concentrate energy into very small regions, space begins to respond. It bends. Not dramatically at first, just enough to hint that something deeper is happening, and as we continue to increase the energy, the bending becomes more pronounced. The geometry of space, something we once thought of as fixed and stable, begins to shift. Distances are no longer what they seemed. Paths begin to curve, and the idea of straight becomes something more subtle. This realization carries with it a quiet sense of awe. because it means that space is not empty. It is dynamic, responsive, connected to the energy within it. And as we continue our journey inward, focusing more and more energy into smaller and smaller regions, this responsiveness becomes increasingly important. It is no longer a background effect. It becomes central to what is happening. The deeper we go, the more energy we must use, and the more energy we use, the more space begins to bend, until eventually the bending becomes so strong that something extraordinary begins to take shape. Not just a curve, but a kind of boundary, a region where the bending becomes so intense that it changes the nature of what can escape. Even light, which we once used as our most reliable messenger, begins to struggle. Its path curves, its escape becomes uncertain, and at some point it can no longer leave at all. But we are not quite there yet. For now, we are still in the stage of realization, still coming to understand that energy is not harmless, that it carries influence, that it shapes the space it moves through, and that the deeper we look, the more we are not just observing the universe, but participating in it, gently at first, then more strongly, until the distinction between observer and environment begins to blur. And as this idea settles softly into place, we begin to follow it just a little further, toward the moment where bending becomes collapse, and space itself forms a boundary from which nothing returns. It may seem simple at first, that energy moves through space, but if we look a little closer, we begin to see that it quietly shapes it as well. At first, the bending is soft, almost unnoticeable. Space curves just slightly under the presence of energy, like a fabric that dips ever so gently when touched. The effect is real but subtle, easy to overlook. But as we continue to focus more and more energy into smaller and smaller regions, something begins to change. The bending grows stronger. Not suddenly, not dramatically, but steadily. Imagine again that stretched fabric. A light object causes only a faint dip, but if you increase the weight, the dip deepens. The surface curves more sharply, and if you concentrate that weight into a smaller area, the effect becomes even more intense. Now imagine pushing this idea further. More energy, packed into less space. The curvature increases, the fabric stretches further, bends more sharply, until the shape becomes something entirely different from what it was before. At some point, the bending is no longer gentle, it becomes overwhelming, and this is where something extraordinary begins to happen. Space does not just curve, it collapses, not in the sense of disappearing, but in the sense of folding inward, creating a region where the geometry becomes so extreme that it changes the behavior of everything within it. This is what we call a black hole. But rather than thinking of it as a mysterious object floating in space, it can be helpful to imagine it as a region where space itself has been reshaped so dramatically that escape is no longer possible, not even for light. You might imagine standing on the edge of a steep valley. At first, the slope is gentle. You can walk freely, move in any direction, climb back up if you choose. But as the slope becomes steeper, your movement becomes more constrained. It takes more effort to climb upward. Gravity pulls you inward, and if the slope becomes steep enough, there comes a point where climbing back out is no longer possible. You can only move inward. In a similar way, when space curves beyond a certain threshold, all paths begin to lead inward. Light, which normally travels freely through space, begins to follow these curved paths, and when the curvature becomes strong enough, even light cannot find a path that leads outward. It is not that something is pulling it back in a traditional sense. It is that the shape of space itself no longer allows escape. This boundary, the point beyond which nothing can return, is often described as the edge of a black hole, but rather than imagining it as a physical surface, it is better thought of as a kind of horizon, a limit, a place where the rules change. If you're outside this boundary, light can still reach you, information can still escape, the world remains connected, but once something crosses that threshold, it is no longer accessible from the outside, it becomes hidden, not because it has vanished, but because the paths that would allow it to return no longer exist. And this is where the connection to our journey becomes clear, because what we have been doing, as we try to see smaller and smaller structures, is concentrating energy into smaller and smaller regions. And as we now understand, concentrated energy bends space. So the question naturally arises, what happens if we concentrate enough energy into a region small enough that the curvature becomes this extreme? The answer is both simple and profound. A black hole forms not as an exotic object created only in distant parts of the universe, but as a natural consequence of concentrating enough energy into a sufficiently small space. And here, something remarkable occurs. The very act of trying to observe smaller scales begins to create a barrier to observation itself, because once this boundary forms, anything within it is hidden. Even light cannot escape to carry information outward, and so, instead of revealing deeper layers of reality, our attempt to look closer begins to conceal them. It is a quiet reversal, a turning point in the logic we've been following. Until now, more energy meant more insight, but here, more energy begins to limit what we can know. It does not sharpen our view, it obscures it. And perhaps the most striking part is this. This is not a limitation of our technology. It is not because our instruments are insufficient, or because we have not yet found the right method. It is a fundamental feature of how energy and space interact. No matter how advanced we become, if we try to concentrate enough energy into a small enough region, this outcome will follow. The universe itself sets the condition, and in doing so, it introduces a boundary, a place where our journey inward encounters resistance, not as a wall, but as a transformation, where the rules we have relied on begin to shift, and as we sit with this idea, we begin to feel its deeper implication. There may be a point beyond which looking closer does not lead to greater understanding, a point where the act of observation becomes self-limiting, and as we move gently toward that realization, we begin to encounter one of the most profound paradoxes in all of physics, because the closer we try to look, the more the universe seems to hide what we are searching for. As the image of curved space settles, of paths bending inward, of light itself tracing arcs it cannot escape, a quiet realization begins to take shape. Up to this point, our journey has followed a simple promise. Look closer, and you will see more. Use more energy, and the universe will reveal deeper layers. It has been a steady rhythm, from atoms to nuclei to quarks. Each step has brought clarity, but now something changes, not abruptly, but unmistakably. The pattern turns back on itself. You might imagine standing at the edge of a foggy landscape. At first, you step forward, and the view becomes clearer. Shapes emerge, details sharpen. The world unfolds gently before you, so you keep going, step by step, deeper into the mist. But then, at some point, the fog thickens, not because you've done something wrong, but because the conditions have changed. The more you move forward, the less you can see. Your effort no longer reveals, it obscures. Something very similar happens as we push toward the smallest scales of reality. We increase the energy. We focus it more tightly. We try to resolve finer and finer details, and for a time, it works. But eventually, the energy we use begins to curve space so strongly that it forms a boundary, a region from which information cannot escape, and once that happens, the very thing we are trying to observe becomes hidden, not far away, not out of reach, but enclosed, shielded by the consequences of our own attempt to see it. This is the paradox. To look closer, we must use more energy, but more energy creates a barrier, so the act of seeing prevents itself. It is not a failure. It is not an error. It is a natural outcome of how reality is structured. You might picture trying to examine something delicate by shining an increasingly intense light on it. At first, the light reveals more detail, but as the intensity grows, the object begins to change. It heats, it shifts, perhaps even dissolves, and beyond a certain point, there is nothing left to observe in the way you intended, but in our case, the effect is even more subtle. The object does not disappear. Instead, the space around it transforms. It closes in, forming a kind of horizon, and beyond that horizon, the information you seek cannot return. So no matter how powerful your tools become, no matter how much energy you can gather, you cannot see beyond that point, because the universe itself does not allow it. And this brings us to a quiet but profound conclusion. There is a limit to how finely we can probe reality, not because we lack the means, but because the act of probing carries consequences that cannot be avoided. You might imagine trying to listen to the faintest sound in a room. At first, you make everything quieter, you remove distractions, you focus your attention. But if you amplify your listening too much, you begin to hear the noise of your own movement, the subtle sounds of your own presence, and eventually, that noise becomes louder than the signal you are trying to detect. In a similar way, as we try to observe smaller and smaller structures, the noise introduced by our own interaction begins to dominate. Except here, that noise is not just a disturbance, it is a transformation of space itself, and so, the closer we try to look, the less we are able to see, not because the details are not there, but because they are hidden behind a boundary that our own methods have created. It is a deeply humbling realization, one that shifts our understanding of what it means to know something. We often think of knowledge as something we can approach indefinitely, that with enough effort, enough refinement, we can uncover every layer, reveal every detail. But here, we encounter a different kind of truth. Some limits are not temporary, they are built into the structure of reality itself, and rather than resisting them, we begin to understand them, to see them not as barriers, but as features, clues about the deeper nature of the universe. Because if there is a limit to how small we can meaningfully explore, then that limit must have significance. It must be telling us something. Something about how space, energy, and information are woven together. And as we follow that thought, gently, without rushing, we begin to approach one of the most remarkable ideas in all of physics, the possibility that there is a smallest meaningful length, a scale beyond which the very concept of distance begins to lose its meaning, a place where closer no longer applies, where the journey inward reaches a kind of natural conclusion. And as that idea begins to form, we move softly toward it, toward a scale so small that it does not simply challenge our understanding, but reshapes it. As the paradox settles, the quiet realization that looking deeper can begin to hide what we seek, another idea begins to emerge. If there is a limit to how finely we can explore, then perhaps there is also a smallest meaningful scale, not just small in the ordinary sense, but fundamentally small, a scale beyond which the very idea of smaller begins to lose its meaning. You might imagine measuring distance with a ruler. At everyday scales, this feels straightforward. You can measure the length of a table, the width of a room, the distance between two objects. And if you want more precision, you use a finer tool, a ruler with smaller markings, a device that can measure with greater detail. And for a long time, it seems as though this process can continue indefinitely. Smaller divisions, finer measurements, ever-increasing precision. But what if, at some point, this process comes to a natural end? Not because we run out of better tools, but because the concept of distance itself begins to blur. Imagine trying to measure something so small that the act of measurement no longer produces a clear answer, not because the object is hidden, but because the space you are measuring does not behave in a stable, well-defined way. It shifts, it fluctuates, it resists being divided further. This is the idea behind what is often called the Planck length. Rather than thinking of it as a specific number, it is more helpful to think of it as a boundary, a scale at which the familiar rules of space and measurement begin to soften, a place where asking how much smaller may no longer make sense. To get a feeling for how small this is, it helps to use comparisons. An atom is already incredibly small, far beyond what we can see directly, and within that atom there are smaller structures still. But this scale lies far beyond even those. If you were to take something already unimaginably small and shrink it again and again and again, layer after layer, you would still not reach this scale. It is not just small, it is profoundly small, so small that it sits at the edge of what can be meaningfully described, and here is what makes it truly remarkable. This scale is not just a limit of our instruments. It is not something we might overcome with better technology, sharper probes, or more energy. As we have gently discovered, trying to probe distances smaller than this scale would require concentrating so much energy that space itself would collapse into a boundary that hides what we are trying to see. In other words, the universe does not simply become difficult to observe at this scale. It becomes fundamentally inaccessible. You might imagine trying to zoom into an image on a screen. At first, you can enlarge it easily. Details become clearer, shapes sharpen. But if you continue zooming, there comes a point where you no longer see new detail. Instead, the image breaks into pixels, and beyond that, there is nothing more to reveal, not because the image is incomplete, but because you have reached the smallest unit from which it is built. In a similar way, the Planck scale may represent something like a pixel of reality, not necessarily a literal grid, but a limit beyond which the idea of smooth, continuous space no longer applies. And this leads to a quiet but powerful insight. Perhaps space is not infinitely divisible. Perhaps it is not a perfectly smooth fabric, but something with a deeper structure. Something that, at its smallest scale, does not behave like a continuous surface, but like a collection of fundamental units, or perhaps something even more subtle. Something that does not fit easily into our usual ideas of shape and size. But regardless of how we interpret it, one thing becomes clear. There is a boundary, a scale beyond which our familiar concepts begin to dissolve. Distance, position, even the idea of here and there, all begin to lose their sharpness. And this is not something to be feared. It is not a breakdown of understanding, but a doorway into a deeper level of reality, a place where new ideas are needed, where the old rules give way to something more fundamental. As we sit with this idea, we begin to feel its significance, because throughout our journey, we have been guided by a simple assumption that by looking closer, by refining our tools, by increasing our precision, we can uncover every layer of reality. But here, that assumption reaches its limit, not as a failure, but as a completion. We have followed the path of observation as far as it can go, and at the end of that path, we find not emptiness, but a boundary that invites us to think differently, to ask new questions, to imagine new possibilities. And as we follow that invitation, we begin to see something even more remarkable, because this smallest meaningful scale does not appear from just one line of reasoning. It emerges quietly from more than one path, different ideas, different approaches leading to the same place. And when that happens, it suggests something deeper, something fundamental. And so, as we continue, we will explore how two very different ways of thinking both lead us to this same quiet boundary, a place where the universe gently reminds us that there are limits, not just to what we can see, but to what it means to see at all. As the idea of a smallest meaningful scale settles gently into place, something else begins to emerge, a quiet sense of reassurance. Because this boundary, this place where distance begins to lose its meaning, does not arise from just one way of thinking. It is not the result of a single theory or a single line of reasoning. It appears more than once from different directions, and when that happens, it invites us to pause, to notice, because when two completely different paths lead to the same destination, it often means that the destination is not an accident. It is something real, something fundamental. So let us follow those two paths, slowly, gently, and see where they lead. The first path, as we've already begun to explore, comes from the idea of concentrating energy. We start with a simple goal, to see something smaller, and we follow the pattern we have learned. To resolve smaller details, we use higher energy. We focus that energy into a smaller region, and at first, this works. Each increase in energy reveals finer structure. But as we continue, the energy becomes so concentrated that it begins to shape space itself. It bends, it curves, and eventually it collapses into a region from which nothing can escape. A black hole. At that point, the process stops, not because we have chosen to stop, but because we cannot continue. Any attempt to go further, to concentrate even more energy into an even smaller region, simply enlarges the boundary. Instead of revealing more, it hides more, and so, from this path, we arrive at a conclusion. There's a smallest region we can meaningfully probe, a limit beyond which further effort does not reveal, but conceals. That is the first path. Now, let us turn to the second. This one begins in a very different place, not with energy and space, but with the act of measurement itself. We return to the idea that to observe something, we must interact with it. We use light or particles to probe its position, and as we saw earlier, the more precisely we try to locate something, the more we disturb its motion. This is the gentle trade-off we explored before, a balance between knowing where something is and how it moves. But now, we take that idea one step further. We imagine trying to measure the position of something with extreme precision. To do this, we must use a very energetic probe. A photon, for example, carrying a large amount of energy, tightly focused. When this photon interacts with the particle we are observing, it does not just reveal its position, it transfers energy. It gives the particle a small push, and as the energy of the photon increases, that push becomes stronger. At first, this is simply part of the uncertainty we must accept, but as the energy grows, something else begins to happen. That photon, carrying energy, also carries influence. As we've learned, energy bends space. So the act of using a high-energy probe does not just disturb the particle, it also affects the space around it. And if we continue increasing the energy, focusing it into a smaller and smaller region, we begin to approach the same situation we encountered before. The energy becomes so concentrated that space itself begins to collapse. And once again, a boundary forms, a horizon, a limit beyond which information cannot escape. And so, from this second path, which began with the act of measurement, we arrive at the same conclusion. There is a smallest meaningful scale, not because we lack precision, but because the very act of increasing precision leads to a condition where observation becomes impossible. Two different ideas, two different starting points, one involving energy and gravity, the other involving measurement and uncertainty, and yet both lead us to the same place, a boundary, a limit, a scale beyond which our usual concepts no longer apply. And this convergence is deeply meaningful. It suggests that this smallest scale is not just a convenient idea or a theoretical curiosity. It is something woven into the structure of reality itself. You might imagine walking toward a distant point from two different directions. From one path, you cross valleys and hills, guided by the shape of the land. From another, you follow a river, winding and gentle, and yet both paths lead you to the same quiet clearing. When you arrive, you realize that the clearing is not defined by the path you took. It exists independently, and in the same way, this smaller scale does not depend on how we approach it. Whether we think in terms of energy and space, or measurement and uncertainty, we arrive at the same conclusion. There is a limit, and beyond that limit, something changes, something fundamental. As we sit with this idea, it begins to feel less like a restriction and more like a guide, a sign that we have reached the edge of one way of understanding and are being invited into another. Because if space cannot be meaningfully divided beyond this scale, then perhaps space itself is not what we thought it was. Perhaps it is not continuous. Perhaps it is not smooth. Or perhaps it is something even more subtle, something that does not fit easily into our usual categories. And as this thought begins to unfold, we're gently led toward a deeper question. What does it mean for distance to lose its meaning? What does it mean for space itself to no longer behave like space? And as we follow that question, we begin to step into a realm where familiar ideas begin to dissolve and new possibilities quietly take their place. As the two paths quietly meet, energy and measurement, gravity and uncertainty, both leading us to the same gentle boundary, we begin to notice something even more subtle. It is not just that we cannot see beyond this scale, it is that the very idea of beyond begins to lose its meaning. Up to this point, our journey has relied on a simple assumption that space is something continuous, that between any 2 points, there is always another point, and another still, a smooth, unbroken fabric. You can move closer, step by step, dividing distance into smaller and smaller parts, without ever reaching a final limit. But now, that assumption begins to soften, because if there is a smallest meaningful length, then the idea of endlessly dividing space may no longer hold. You might imagine looking at a digital image. From a distance, it appears smooth, continuous. The colours blend gently into one another, forming a seamless picture. But as you zoom in, closer and closer, something changes. The smoothness begins to break apart. What once looked continuous is revealed to be made of tiny, discrete units, pixels. And beyond those pixels, there is no further detail to uncover, not because the image is incomplete, but because that is the level at which it is defined. Now, this analogy is not perfect. Reality is not simply a grid of tiny squares, but it hints at something important, that the smoothness we experience may be an emergent property, something that appears at larger scales, but does not exist in the same way at the smallest ones. As we approach this fundamental scale, space may no longer behave like a smooth fabric. Instead, it may fluctuate, shift, resist precise definition. You might imagine standing on solid ground. At everyday scales, it feels firm, stable, predictable. But if you could somehow zoom in far enough to the level of its smallest components, that solidity would disappear. It would become a dance of motion, of interactions, of tiny structures constantly shifting. Now imagine going even further, beyond atoms, beyond the structures we already know, into a realm where even those patterns begin to dissolve. At that level, space itself may no longer have a fixed shape. It may ripple, not like a gentle wave, but like a restless surface, a kind of subtle, ever-changing texture, sometimes described as a foam, not because it looks like foam, but because it is dynamic, fluctuating, never entirely still. And within this restless structure, the idea of a precise location begins to fade. If space itself is shifting, then what does it mean to say that something is here or there? If the very geometry of space is uncertain, then distance is no longer a simple measure. It becomes something softer, more abstract, and this has implications not just for space, but for time as well. Because in our everyday experience, space and time are closely connected. We think of events as happening at a certain place, at a certain moment. But if space loses its clarity, then time may also begin to lose its sharpness. The distinction between before and after, between cause and effect, may become less well defined, not in a chaotic or confusing way, but in a way that reflects a deeper level of structure, one that does not follow the same rules we're used to. You might imagine trying to describe the motion of something in a dream. Events flow, but not always in a strict sequence. Locations shift without clear boundaries, and yet there is still a kind of coherence, a deeper logic, just different from the one we experience while awake. In a similar way, at these smaller scales, reality may still have structure, but not one that fits neatly into our usual concepts of space and time, and this leads us to a quiet but profound insight. Perhaps space and time are not fundamental. Perhaps they are not the most basic ingredients of reality. Instead, they may be something that emerges, something that arises from deeper processes, from patterns we do not yet fully understand. At larger scales, those patterns give rise to the smooth, continuous world we experience. But at the smallest scales, the underlying structure reveals itself, and it is different, not broken, not chaotic, but subtle, difficult to describe using familiar language. And this is why the Planck scale feels so strange, not just because it is small, but because it challenges the very concepts we rely on to make sense of the world. Distance, position, time, all begin to blur, and in their place, we're left with something more abstract, a kind of foundation that does not behave like anything we encounter in everyday life. As we sit with this idea, it may feel a little unsettling at first, to realize that the familiar framework of space and time may not extend all the way down. But there is also something deeply calming about it, because it reminds us that our understanding, while powerful, is not complete. that there are layers of reality still waiting to be explored, and that the boundaries we encounter are not dead ends, but invitations to think differently, to imagine new possibilities, to develop new ways of describing what lies beneath. And as we follow that invitation, we begin to step into a new phase of our journey, one where we ask not just what the limits are, but what might lie beyond them. What new ideas might help us understand a world where space is no longer smooth, and distance is no longer simple? And as that question begins to unfold, we're gently guided toward the theories that attempt to answer it. As the idea settles, that space may not be smooth, that distance itself can soften and blur, a new question begins to form. If space is not fundamental, then what is? If the familiar picture of tiny points moving through empty space no longer holds, what replaces it? And in response to that question, one of the most imaginative ideas in modern physics quietly emerges, an idea that suggests that at the deepest level, reality may not be made of points at all, but of tiny, vibrating strings. At first, this might sound almost poetic. Strings, not in the sense of something you could hold or see, but in the sense of something extended, something with a subtle length, even at the smallest scales. Instead of imagining particles as infinitely small dots, this idea invites us to picture them as tiny loops or strands, gently vibrating. Each vibration corresponds to something we observe. A different pattern of motion gives rise to a different kind of particle. It is a bit like a musical instrument. Imagine a single string on a violin. When it vibrates slowly, it produces a deep, low sound. When it vibrates more quickly, the sound becomes higher. The string itself does not change, but the way it vibrates creates different experiences. In a similar way, these fundamental strings, if they exist, could give rise to all the particles we observe simply through different patterns of vibration. Electrons, quarks, even the particles that carry forces could all be different notes played by the same underlying structure. And this idea carries with it a quiet but important consequence, because if particles are not points, but have a small finite size, then there is a natural limit to how precisely we can probe them. You can no longer zoom in indefinitely, because there is something there that cannot be compressed into a single point. The string itself has an extent, and as you try to probe it with higher and higher energy, something unexpected happens. Instead of revealing smaller details, the string begins to respond. It vibrates more intensely. Its motion becomes more complex, and in a sense, it spreads out. You might imagine plucking a string more and more strongly. At first, the sound becomes louder, clearer. But if you continue increasing the energy, the vibration becomes more chaotic, more expansive. The string does not shrink into a smaller point. It becomes more active, more extended in its motion. And so, the familiar pattern, more energy leads to finer resolution, begins to change. At this scale, more energy does not help you see smaller. It simply excites the system in a different way, and this provides a natural explanation for the limit we have encountered. Why there is a smallest meaningful length. Not because space itself imposes it directly, but because the fundamental objects we are probing cannot be reduced beyond a certain scale. They are not points, they are extended. And this idea, while simple in spirit, leads to a rich and complex framework, one that suggests that reality may have more dimensions than we experience. Not just the 3 dimensions of space and one of time, but additional directions, hidden, compact, curled up at scales far beyond our perception. These extra dimensions are not something we can easily visualize. They do not extend outward like the space around us. Instead, they are thought to be tightly folded, existing at scales so small that they escape direct observation. And within this higher dimensional structure, the strings vibrate, their patterns shaped not just by the space we know, but by these hidden dimensions as well. It is a beautiful idea, one that attempts to unify many aspects of physics, bringing together particles, forces, and geometry into a single framework. And perhaps most importantly, it offers a way to understand the limit we have encountered, because if everything is built from strings, and those strings have a finite size, then the Planck scale is not just a mysterious boundary, it's a natural consequence, a reflection of the smallest structure from which reality is composed. But as with all such ideas, it is not the final word. It is a possibility, a direction, a way of thinking about the problem that opens new doors, even as it leaves some questions unanswered. And there are other approaches as well, other ways of imagining what lies beneath the smooth surface of space. Some do not replace particles with strings, but instead suggest that space itself is made of discrete building blocks, tiny units, connected in a network, forming the fabric of reality in a different way. And as we continue, we will explore that possibility too. Because at the edge of understanding, there is rarely just one path. There are many, each offering a different perspective, a different way of seeing, a different kind of insight. And together, they form a kind of quiet landscape, one where certainty gives way to exploration, and where the smallest scales of reality invite us not to conclude, but to wonder. As the image of vibrating strings slowly fades into the background, another possibility begins to take shape, a different way of thinking, not about replacing particles with something extended, but about questioning space itself. What if space is not continuous? What if, instead of being a smooth, unbroken fabric, it is made of tiny building blocks? At first, this might feel unusual. We're so used to imagining space as something that stretches endlessly, something you can divide again and again without limit. You can always move halfway between 2 points, and then halfway again and again, without ever reaching a smallest step. But what if that intuition, while useful at everyday scales, does not hold at the deepest level? You might imagine standing on a beach. From a distance, the sand looks smooth, like a continuous surface. But as you walk closer, you begin to see that it is made of individual grains, tiny discrete pieces, each separate, each with its own shape. And if you go closer still, you cannot divide a grain of sand into smaller grains of sand. You have reached the level at which the structure is defined. Now, this analogy is not exact, but it offers a gentle way to picture the idea. That space itself might be composed of something like grains. Not grains in the usual sense, but fundamental units, the smallest pieces from which the structure of space is built. In one approach to understanding the Planck scale, often referred to as loop quantum gravity, this idea is taken seriously. Instead of imagining space as smooth and continuous, it is described as a network, a kind of woven structure made of tiny connections. You might picture it like a web, not a web stretched across a surface, but a web that is the surface itself. Each connection, each tiny link contributes to the shape of space, and together they form a structure that, at larger scales, appears smooth, but at smaller scales reveals its discrete nature. In this picture, space is not something that exists independently. It is something that emerges from relationships, from connections between these fundamental units, and this leads to a quiet but powerful shift in perspective. Because if space is made of discrete building blocks, then there is a natural limit to how finely it can be divided. You cannot go between the smallest units, just as you cannot step between the grains of sand without stepping on one. The concept of distance itself becomes quantized, not in the sense of sharp steps you can easily observe, but in the sense that there is a smallest meaningful increment, a smallest unit of area, a smallest unit of volume. Beyond that, the idea of further division no longer applies, and this connects beautifully with the limit we have already encountered, the Planck scale, not as an abstract boundary, but as a reflection of the underlying structure, a hint that space itself may not be infinitely divisible, but composed of something more fundamental, something discrete. And yet, just like the sand on the beach, this discreteness is not visible at everyday scales. When you walk along the shore, the sand feels continuous beneath your feet. You do not notice the individual grains unless you choose to look closely. In the same way, the discrete structure of space, if it exists, would be hidden at the scales we experience. Space would appear smooth, continuous, just as it always has, only at the smallest scales, far beyond direct observation, would its true nature begin to reveal itself. And this leads to another gentle insight, that what we perceive is not always what is fundamental. The smoothness of space, the continuity of distance, may be emergent properties, features that arise from deeper, more subtle structures that do not resemble the world we are familiar with, but give rise to it. And there is something quietly beautiful about this idea, because it suggests that the universe, at its deepest level, may be built from simple elements, connections, relationships, patterns that, when combined, create the richness and continuity we experience. Not unlike how individual notes can combine to form music, or how individual pixels can combine to form an image. And just as with those examples, the underlying structure is not immediately visible. It reveals itself only when we look deeply enough. But as we have seen, there is a limit to how deeply we can look, and so these ideas remain, for now, just beyond direct reach, guiding our understanding, but not yet fully confirmed. And yet, even without direct observation, they offer something valuable, a way of thinking, a framework that helps us make sense of the boundary we have encountered. Why there is a smallest meaningful scale, why space may not behave as we expect at the deepest level, and why our journey inward leads not to a simple point, but to a transformation of the very concepts we rely on. As we sit with this idea of space as a network, as something built from tiny, interconnected pieces, another possibility begins to emerge, one that shifts the perspective even further. Because what if, at the deepest level, reality is not made of things at all? Not strings, not grains, not even building blocks, but something more abstract, something like information. And as that thought begins to form, we gently move toward the final layer of this exploration. As the image of space as a network slowly settles, threads and connections forming a quiet structure beneath everything we experience, another idea begins to emerge, even more subtle, even more abstract. What if, at the deepest level, reality is not made of things at all? Not particles, not strings, not even tiny building blocks of space, but something more like information. At first, this might feel difficult to grasp. We are used to thinking of the world in terms of objects, things we can point to, touch, and describe. Even when those things become very small, we still imagine them as something, But information is different. It is not a substance. It is a description, a pattern. You might think of a photograph stored on your phone. The image feels real. It shows shapes, colours, faces, moments in time. But if you look closely, the photograph is not made of those things. It is made of data, arrangements of bits, tiny pieces of information that, when interpreted, give rise to the image. The picture is not stored as a tiny scene inside the device. It is encoded. And something similar may be true of reality itself. This idea begins to take shape when we look again at black holes, those regions where space curves so deeply that nothing can escape. For a long time, black holes were thought to simply swallow everything that fell into them, information included. But this created a problem. Because in physics there is a deep expectation that information is not lost, that the details of a system, even if they are transformed, remain in some sense preserved. So the question arose, what happens to the information that falls into a black hole? And the answer that began to emerge was surprising. Rather than being lost, the information may be stored. Not inside the black hole in the way we might imagine, but on its boundary, on the surface that separates the inside from the outside. You might picture it like a sphere, all the information about what has fallen in, encoded on its surface, like a kind of cosmic record. And what is even more remarkable is that the amount of information that can be stored appears to be related not to the volume of the region, but to the area of its surface. This is a subtle but profound shift. In our everyday experience, we think of information as filling space. A larger volume can hold more, but here, the surface becomes the key, and from this idea, a new perspective begins to unfold, one that suggests that perhaps the three-dimensional world we experience is in some way a projection, an expression of information encoded on a lower dimensional boundary. This is often referred to as the holographic principle, and while the name may sound technical, the idea can be approached gently. You might imagine a hologram, the kind that appears on certain cards or displays. It looks three-dimensional, as though it has depth and structure. But in reality, all the information is stored on a flat surface. The depth you perceive emerges from the way the information is encoded. In a similar way, it is possible that the space we experience, with all its depth and richness, arises from information stored on a more fundamental surface, not a surface we can see directly, but one that underlies the structure of reality. And this connects back in a quiet way to the Planck scale. Because if there is a smallest meaningful unit of area, a smallest pixel of surface, then information itself may be quantized, stored in discrete units, not infinitely divisible, but built from fundamental pieces. And this offers another way of understanding the limit we've encountered. Why there is a smallest meaningful length. Why space does not behave smoothly at the deepest level. Because beneath the smooth appearance, there may be a finite amount of information, arranged in a specific way, a structure that cannot be refined indefinitely, because it is already at its most basic level. And this leads to a gentle but powerful shift in perspective. Instead of asking, what is reality made of? We begin to ask, how is reality described? What patterns, what relationships, what information give rise to the world we experience? And this does not mean that matter disappears, or that space and time are illusions in a simple sense. It means that they may be emergent, that they arise from something deeper, something more abstract, something that does not look like the world we're used to. And as we sit with this idea, it can feel both unfamiliar and strangely calming, because it suggests that beneath the complexity of the universe, there may be a kind of simplicity, not in the form of objects, but in the form of patterns, relationships, information. And just as a simple set of rules can generate a complex image or a piece of music, so too might the universe emerge from a deeper layer of encoded structure, a layer we are only beginning to glimpse, and perhaps that is where the true mystery lies, not in the smallest objects, but in the patterns that give rise to them. As this thought gently settles, we begin to approach the final stage of our journey, a place where we step back and reflect, not on what we have found, but on what it means, on the nature of limits, on the boundaries of knowledge, and on the quiet realization that sometimes understanding does not come from seeing further, but from recognizing where the path itself comes to rest. If we linger with that thought for a moment, that reality may be woven from information, patterns within patterns, something deeper than objects or space itself. We begin to arrive at a quiet place, not a final answer, but a resting point, a place where the journey inward naturally comes to pause. Throughout this exploration, we have followed a simple instinct, to look closer, to move inward, step by step, layer by layer, from the world we see to the structures beneath it, and then beneath those, again and again. And for a long time it seemed as though this journey could continue forever, that with enough care, enough energy, enough precision, we could always go further. But what we have found is something different, not a wall, not a sudden end, but a gentle boundary, a place where the rules we rely on begin to soften, where space is no longer clearly defined, where distance becomes uncertain, where even time may lose its familiar flow, and at that boundary, something important becomes clear. Physics does not fail, it does not break. It simply reaches the edge of where its current language can go. You might imagine reading a book written in a language you know well. Page after page, everything makes sense. The story unfolds clearly. Each sentence builds on the last. But then, as you reach the final pages, the language begins to change, not abruptly, but gradually. Familiar words begin to fade, replaced by new ones, unfamiliar ones, carrying meanings you can almost sense, but not quite fully grasp. The story has not ended, but your way of understanding it has reached its limit. In a similar way, as we approach the Planck scale, the concepts we have relied on, space, time, position, motion, begin to lose their sharpness, not because they are wrong, but because they belong to a larger scale, a scale where the patterns of reality average out into something smooth, something continuous, something we can describe with clarity. At the deepest level, those patterns are still there, but they no longer fit neatly into our familiar framework, and so we are invited to do something different, not to push harder, not to force clarity where it no longer applies, but to pause, to reflect, to recognize that understanding has many forms. Sometimes it comes from seeing more, and sometimes it comes from recognizing the limits of seeing. This is not a limitation to be feared, it is a kind of guidance, a sign that we are approaching something fundamental, because limits, when they appear consistently, often point to deeper truths. The Planck scale, this smallest meaningful length, is not just a boundary, it is a clue, a hint that the structure of reality is not infinitely divisible, that it has a kind of resolution, a deepest layer beyond which our usual questions no longer apply. And beyond that layer, there may be new ways of describing the world, ways that do not rely on distance, or position, or even time in the way we understand it. We have already glimpsed some of these possibilities, strings, gently vibrating, giving rise to particles, networks, forming the fabric of space itself. information encoded on surfaces, shaping the world we perceive. Each of these ideas offers a different perspective, a different language, none complete, but each pointing towards something deeper. And perhaps that is the most important realization of all, that the journey inward is not just about finding smaller pieces, but about discovering new ways of thinking, new ways of describing what lies beneath. And as we sit with this, there is something quietly comforting about it, because it reminds us that the universe is not something we fully possess. It is something we explore, something we approach gently, with curiosity, with patience. And even when we reach a boundary, even when the path becomes unclear, there is still something there. Not emptiness, but possibility. You might imagine standing at the edge of a vast landscape at night. The horizon stretches out before you, fading into darkness. You cannot see beyond it, not because there is nothing there, but because your current view does not reach that far. And yet, you know that the landscape continues. In the same way, the Planck scale is not the end of reality. It is the edge of what we can currently describe. A place where our understanding, like our vision, gently fades, and beyond it, something remains, something waiting to be understood in a different way, with a different language, perhaps even a different kind of intuition. And so, we come to rest here, not with a final answer, but with a quiet appreciation for the journey we have taken, for the patterns we have uncovered, and for the boundaries that guide us, not as obstacles, but as invitations to continue in new ways at another time. And so, as this exploration gently comes to a close, whether your thoughts are still drifting or beginning to fade into sleep, thank you for being here, for following this journey into the smallest scales of reality, where even space begins to whisper. And wherever you are, and whenever you may be listening, may your mind rest softly in the quiet wonder of it all.